acid in rainwater has slowly eaten away at the limestone bedrock. The result is a vast underground landscape of cliffs, cavities, and fissures, ranging in size from tiny cracks to colossal caves. In Kuala Lumpur, most people don't know they're there until they collapse and bring down the city with them. From the start, engineers knew that building the SMART would require sending the tunnelers and their machines straight into this underground minefield. The stakes are huge. If one of the giant drills hits a large, unstable cavern, it could trigger a monstrous sinkhole. Wherever they occur, sinkholes can come in all shapes and sizes. This one in Guatemala was 40 meters wide. It sucked down houses and killed 3 people. It wasn't caused by tunneling. It occurred suddenly after a major rainstorm. If a sinkhole this large happens in Kuala Lumpur, the results could be catastrophic. It's not the first time engineers have faced this danger. Rewind to 1992. Plans are underway to build the Petronas Twin Towers on a site in downtown Kuala Lumpur. They would be 88 stories tall, the highest twin towers in the world. Together, their concrete and steel would weigh more than 400,000 metric tons. Place that much weight on unstable ground, and the results could be disastrous. So before construction began, geologists launched a massive site survey. And luckily, they made a crucial discovery. Under the planned site was a giant limestone cliff that could have caused the towers above to sink and even collapse. The original site had to be moved 60 meters. But building the SMART tunnel would be much more complicated. The Twin Towers rested on just over 18,000 square meters of ground, an area small enough to survey completely before construction started. SMART, on the other hand, has a 10-kilometer-long footprint. Its site covers almost 7 times as much ground as the Twin Towers. Surveying every single inch of this much earth isn't an option. To reduce the risk of collapse, geologists have to probe constantly ahead of the TBMs.
We were probing ahead of the machine, and we were always looking for solution features which were large enough to allow the machine to drop into or tip into, because it would have stopped tunneling for months.
Whenever the surveyors hit a cavity, they pump it full of concrete-based grout. But karst cavities can be less than a meter wide, making it nearly impossible to locate every one along the tunnel's entire route. SMART's long underground journey meant that the tunnelers would face new risks every single day, month after month, for almost 3 years. With so much at stake, the choice of TBMs was critical. The way most tunnel boring machines work is surprisingly simple. The cutter head at the front grinds through soil and rock, much like a household drill. The resulting waste is then loaded on wagons and carried out of the tunnel. This kind of TBM is designed for solid ground. If the drill hits weak cavities, like those under Kuala Lumpur, the earth could cave in on the cutter head. A big enough collapse could even suck the TBM down with it. The TBMs chosen for SMART are specially armed. Their advantage is a sealed high-pressure chamber at the head of the drill. This is pumped full of liquid called bentonite slurry. The intense pressure of the slurry on the rock face fills cavities before they can collapse as the TBM grinds forward. The sealed pressure zone also provides a barrier between the tunnelers and the unstable ground ahead of them. At least, until something goes wrong. Inside the TBM in the North Drive, there's a problem. The giant drill's progress has slowed dramatically. The team needs to find out why. The TBM's cutter head is armed with 76 forged steel discs to tear through rock and soil. Gus believes the cutter discs have worn down and may need to be replaced. The problem is, the cutter head lies in the forward pressure zone. To get there, the workers have to wait it out in a hyperbaric chamber until it's safe to go inside. The cutter head compartment has been drained of slurry so the men can work. But if the TBM is stopped inside a weak karst cavity, a sudden drop in pressure could cause the ground ahead to cave in. First, shift engineer Hawaii needs to measure the cutter discs. To access each disc, he has to rotate the giant drill. One wrong move and the rock face could weaken. The cutter discs are too dull to continue tunneling. They'll have to be replaced. Inside a pressurized cutter head are some of the worst conditions a tunneler can face. It's noisy. It's hot, with temperatures up to 45 degrees Celsius. And there's barely enough space to move. Speed is critical. Every time the cutter head moves, there's a new risk of falling rock and soil. Finally, the first cutter is free. Replacements arrive through a pressure lock. Each cutter is forged from tool steel, some of the hardest metal on the planet, and weighs 200 kilograms. Working in shifts, it takes 64 hours to finish the job. For Gus, the sound of the drill ramping back up to speed is a welcome sign that the problem is over.
You can hear the cutter head starting up now, this wah, wah, wah noise. Means the machine is excavating again. The cutter head drive is 4,000 kilowatt. It's quite something. I love this noise. It means the machine is working well. It's fantastic. Hi, Rob. What's up?
Keeping the machine serviced and on schedule is Gus's priority. But he also has to make sure the TBM follows a precisely defined path. The ideal route for the Smart would be a straight line, but unfortunately, that wasn't an option. The reason may be surprising: local property law. In Malaysia, property owners don't just own their land, they also own everything that lies below it, all the way to the core of the earth. Since the tunnel's original route would send it careening into hundreds of private property plots, city officials would have to buy tunneling rights from each landowner, including one of Kuala Lumpur's most exclusive golf clubs. And that would have added millions of dollars to the project's cost. The solution was to send the giant tunnel under land already owned by the city, including streets and highways. But now, the Smart would require a series of sharp bends. Turning a 4-story high drill that's as long as a city block 20 meters underground isn't easy. An experienced tunneler, Gus knew what it would take.
We tried to make the minimum curves what is possible with this size of tunnels. 250-meter radius is a very, very small curve for a size of tunnel like this. And as a consequence, we had to buy special machines to be able to negotiate this curve.
A special giant bearing was installed at the front of the TBM to enable the drill head to navigate the tight turns. and high-grade ring segments had to be specially fabricated to make the tunnel lining turn too. Each ring has a thick side and a thin side. If you put the thin sides back to back, you can make the tunnel turn any way you want it. The TBM team is under constant pressure to finish the Smart on schedule. But just behind the tunnelers, another challenge is looming.
When we're building the tunnel, we don't have the access of the whole tunnel. The road deck construction is right behind us, chasing us, if I can say that.
The Smart's design calls for a double-level 3-kilometer roadway to be built inside the tunnel. The problem is, they have to construct it less than 300 millimeters above the moving trains that carry crucial supplies to teams working deep inside. Many said it couldn't be done. The solution? To build just 2 key supports on either side of the train track, and then use the lining of the tunnel itself to help suspend huge precast slabs over the train. On top of these slabs, workers can pour the concrete for the road decks, while the train below keeps running round the clock. June 4th, 2005. Across town, one of the TBM teams is reaching a critical project milestone: breakthrough in the South Tunnel. After drilling for 9 months and building 1,067 rings, the South Drive TBM emerges right on target. But risks to the project continue, including what no tunnel operator ever wants to see. Tunnelers are more than 2 years into their big dig to build the giant Smart Tunnel under Kuala Lumpur, Malaysia. The tunnel will be the first of its kind on the planet, a combined roadway and flood channel that can protect this Southeast Asian city against future giant floods. Critical repairs to the tunnel boring machine in the North Drive brought tunneling to a halt. Now, the giant machine and its crew are back on schedule, racing again toward completion. After 3 years, the double-level roadway is finally open for business. But now, the lives of commuters will be at stake too. Thousands of vehicles are expected to travel through the tunnel every day. In just seconds, a single driver could trigger a major accident. It's every tunnel operator's worst nightmare. A horrific scene like this one. It happened in the Alps, right on the border of Italy and France. It's March 1999. Deep inside the Mont Blanc tunnel, a truck carrying margarine has caught on fire and triggered a raging inferno. Cars and passengers already inside have no